Hello and welcome to another episode of Carbohydrate discussion series. Today, Abhishek will present synthesis of some oligopyridine galactose conjugates and their metal complexes. Let's begin the session.
Multivalent sugar ligand. Abstract of these papers, some galactose oligopyridine conjugates were readily assembled by combining different functionalized oligopyridine with per-acetylated galactose derivatives. Variation in the structure of the components and of the linkers employed for their connection afforded adduct for different size, shape, and conformational mobility. Complexation of the bipyridine ligand with copper triplet and of the terpyridine ligand with zinc triplet afforded the corresponding polystylated in 2:1 and 1:1 complexes, respectively, as a single species. Their structures were determined to be tetrahedral copper complexes and TBP trigonal bipyramidal zinc complexes on the basis of spectroscopic evidence. Removal of the acetyl protecting group from the ligand afforded the corresponding polyols. The terpyridine zinc 2 complex, unlike the bipyridine copper 1 complex, maintain their structure upon removal of the steel protecting group. Protein carbohydrate interaction control a variety of fundamental biological process. In many instances, several carbohydrate units are involved in the binding event to take advantage of the so-called glycoside cluster effect. Artificial multivalent glycoside ligand have been synthesized with the aim of better understanding the protein carbohydrate interaction processes and of developing inhibitors of these phenomena when they are involved in the infectious cycles. This is surprising because of the metal assisted association of carbohydrate component modified with the metal binding ligand can open a straightforward access to carbohydrate clusters in which the number and the relative orientation of the carbohydrate residues can be modulated almost at will by changing the structure of the ligand and the nature of the metal. Coming to this synthesis result and discussion, they synthesize these 2, 3, 4 molecules by taking as a TCA donor synthesis of galactose derivatives 2 to 4. They use activating agent TMSO-TF by taking this acceptor in DCM as a solvent to synthesize this compound 2. Then further reduce by reduce this amine to this protecting group to amine by H2BTC. And in B and C, they use a different acceptor by using same activator TMSO-TF, and they use like this phenyl as well as this acceptor to synthesize these 3 and 4 molecules. Toward the synthesis of this oligopyridine 5, 6, and 10, and the synthesis of bipyridine 8 and 9, starting from this compound, they take 3-formyl phenyl boronic acid. This is some Suzuki type coupling, then followed by a nickel promoted homocoupling, is NiCl2 hexahydrate. Then at last, by reducing with NaBH4, they got this 8B compound. Further, by reaction with PBr3 DCM, they converted this alcohol into bromine, and they synthesize this 10 compound as a starting material for forward reaction. Then by taking 3 and 5, by taking these 3 molecules, these 3 compound and this 5, they did the reactions by using this condition cesium carbonate and stone ethyl room temperature for 18 hours. They synthesize this bipyridine compound and further deprotected sodium ethoxide to get the final deprotected compound. And in this, they take 4 and 6. This 4 compound and as this oligopyridine 6 to do this Suzuki type coupling reaction to form this coupling product. And in third, they take this compound 3 and this after this D product, this bromine 1, and the condition is sodium carbonate DMF acetonitrile in Ht80:20. They synthesize this oligopyridine compound with the both side glucose derivatives. And in entry 4, they take 2 and 8 this glycosyl amine, this amine 1 2, and this one is a 4 to synthesize. This is the final molecules, and the condition is like methanol DCM in 20:80 ratio at room temperature. And in last, they take 4 and 10. This 4 and these final molecules, what they are synthesized in the synthesis of oligopyridine, synthesize these molecules. And finally, they reported for after synthesizing these final molecules, their formation of complexes copper as well as formation of complex zinc. The formation of complex copper 11 to copper 14 was performed in 92 to 98% yield by addition of 1 mole of equivalent of copper tiflate to 2 mole equivalent of ligand 11 to 14 in 50:50 acetonitrile chloroform to afford after the solvent evaporation dark red solid. And in these zinc complexes, this reaction of ligand 15 and 1 mole equivalent of zinc tiflate in chloroform afforded this 1:1 zinc complexes, and they reported that this copper complexes is a tetrahedral, and this zinc complex is a TVP trigonal pyramidal structure by the NMR and mass spectrometric evidence. What they observed in this reaction to confirm that this is a diagonal pyramidal and tetrahedral structure, the segment of a structure to these complexes was based on NMR evidence. In all cases, 13C NMR signals of the bipyridine carbon were shifted downfield by 4.3 to 4.6 and 1.1 to 1.9 ppm respectively upon complexation. And opposite shift was experienced by the quaternary carbon of bipyridine that was shifted by 2.8 to 3.7 ppm. And these trends are in the agreement with those generally observed in the C60 disubstituted bipyridine unit complex copper 1 cation to afford a tetrahedral adduct. And further support in favor of the formation of tetrahedral arranged complexes copper 11 to copper 14 is also come from the variation in the chemical shift observed for the proton of the residues in the vicinity of the bipyridine nuclei. Inspection of the molecular models showed that upon formation of a tetrahedral complex, proton of one ligand molecules fell in the shielding cone of the bipyridine moiety of the other ligand molecules. As a consequence, strong field shift expected and indeed observed. For instance, the signal of methylene group bound in bipyridine in ligand 11 was shifted about 0.5 ppm of field in copper 11 complexes. In conclusion, this work has demonstrated that galactose oligopyridine conjugate could readily be assembled by combining 4 different functionalized bipyridine and 1 terpyridine with the 3 per acetylated galactose derivatives. Variation in the structure of the component and of the linker employed for their connection afforded adduct of different size, shape, and conformation moiety, thus showing the generality of this approach. Complexation of the bipyridine ligand with copper tiflate and of terpyridine ligand with zinc tiflate afforded the corresponding peristylated in 2:1 and 1:1 complexes respectively as a single species. This structure were determined to be tetrahedral and TVP by the NMR and spectroscopic evidence. Removal of the sterile protecting group from the ligand was possible, afforded polyols that turned out to be poor soluble in most organic solvent and in water. In contrast to the terpyridine zinc 2 complex, the bipyridine copper 1 complex survived in the removal of the steel protecting group and maintained their structure. Studies dedicated to assess the binding ability of this multivalent glycosylated ligand on macromolecular receptors such as lectin by turbidimetric analysis will be reported in due course. Thank you.
Abhishek,
Yeah,
where they explained the NMR studies, they have directly given the sentences only, or they have some NMR data.
like by NMR data, they are concluding that before complexation of metal and after complexation of metal, they are deshielding and shielding effect are
No,
observed.
there are some comparing NMR, like figures are there, comparing figures. Okay, this
No,
shift is there.
I tried to search that NMR where they mention, but I didn't find that NMR. They're giving the NMR value actually, but they are not comparing the NMR data before and after.
Okay. Okay, so what they did with this complexes again? They have studied something.
No,
Make it
no.
full screen, make it. Okay, once they synthesize this compound with spacer,
Only
they form two complexes, one with the copper complex, another one with the zinc complex.
zinc complex.
After that, what they
they reported that one is like by spectroscopy, one is the tetrahedral and one is in TBP form.
Okay, so there is no any interaction. Okay, something application is not there with this
No,
compound.
nothing. Like they are mentioned about this ligand binding study, but they didn't study in this paper. They didn't go for this glycosylated ligand on this molecule.
Okay. Okay, nice.
Good presentation, Abhishek.
Yes.
Which
Thank
spectroscopy
you.
method they use for this find out this structure?
I think XRD.
Or they use this crystal chem, this compound crystal formed. But they don't show crystal structure here.
They don't show crystal structure. They are not mentioning about XRD here. They are saying that on the basis of NMR and spectroscopic study, one is copper complex is a tetrahedral and zinc complex is a TBP.
Yeah, this is fine, but any supporting information because without crystal structure and NMR is so much complicated to find out the structure in these complexes.
But they are not like mention any XRD and some other spectroscopic method. I don't see.
By the way, while comparing the structures, which difference they observed? Actually, you told in the sentence, but by looking the structure, okay, this value change, that value change, something.
This value change,
Make it full screen. Make it full screen.
Before complexation and after complexation, same molecules. But,
so what is changed there? Which values changed?
Value change is this one. This bipyridine one. This chemical shift downfield and upfield when they are coming in the range of metal. They are saying here, here saying that the opposite shift was experienced by quaternary carbon of bipyridine. That was shifted by upfield by this one. Here, this bipyridine, when they are in contact with the metal, then by comparing this, they are saying about this TBP and tetrahedral.
Which quaternary carbon they are talking about? Because once it will
No,
deshield.
this quaternary carbon, this quaternary carbon, I
Okay.
think.
Okay.
This is
So
only quaternary
value
and this one.
values are decreasing.
This carbon and this carbon. I think
Okay,
this,
but that
this
those
is,
values are decreasing.
that was shifted upfield by this 2.8 and 3.7 ppm.
How it is shifting? According to the electronics, there is a deshield, right? If the nitrogen is donating electron to the copper, there will be the deshield
this
for that.
nitrogen, like this is because of copper and zinc, na. So
That's
while
fine.
chelation, they are more shaded.
They are using different spacer also, but here they have showed only one. Like they have made 3 spacers, right?
They have made 3 spacers here, 2, 3, and 4.
So how that is affecting this coordination? They might have said something. From that they are selecting this third one, right? Fourth. You go to the title of the paper. What is their target? Oligopyridine galactose conjugate and their simple entry. This is very old paper. Okay.
I think after that they have did something in another paper maybe.
So this is metal complexes only they wanted to make using this oligopyridine galactose. Okay. So they didn't mention anything about the other spacers because finally they are using this.
This 4-1.
Maybe in other cases the desired complexation they might not be getting. That's why they are changing the spacer, right?
I think so.
Good. So what about this glycosylation? They have shown from 1 to 4, like in this slide only. And 1, 1, 2, 3, like they haven't mentioned the yield. What about the
Yield.
how good this glycosylation is there with hydrophenol?
Like in this paper also they didn't mention about the yield.
So nowhere they have written. They have written, I guess.
Okay, it is written 85% yield.
Okay, which the 4 they got in 85%.
85%. And 3, and they got this one is a 50% yield and 33% yield.
It is not that much nucleophilic, right? Phenol is there generally, so that OH is not that much nucleophilic for the glycosylation.
So they have written here 85% yield, 78 to 22 mixture of anomers.
Both the anomers alpha beta and then
There
finally
alpha beta both. Although
beta is they got 66% finally.
Okay.
So for them this anomer is also important. They wanted beta only. Like it has some role in this coordination.
I don't think so in coordination, but their final title is there na, with the lectin binding. For that purpose, this beta is important in case of PNA studies if you wanted to do. Alpha will not be there that much bind.
So two ligands are binding since bipyridine moiety is there. So both are. You go to that metal complex.
This one.
Oh. Okay. So one is tetrahedral.
And one is TPP.
So that is changing just based on the metal core, not based on the ligand.
Yes, yes. Actually, I also didn't understand that animal is fine, but how this mass spectroscopic evidence can prove that this is TPP and this is tetrahedral on the basis of mass spectroscopy.
So since you're telling right, they have concluded based on the NMR, that can be done probably. Okay, good. Hello.
Hello.
No one else has question. So you are recording
Okay.
this lecture, Mahesh?
Yes.
Oh, good.
Can I stop?
1 second. Hey, Bharat Singh Dada, you don't have any question?
No.
Adarsha on the hold. By the way, I don't know where he is.
So why you chose this paper? Like
This, I'm reading this Palestine paper na. So in that paper, they're following this paper. So
means.
from there,
So,
I got this paper.
so what they are following from? Like
From
what is there of
this.
your interest? This
They are
linkers.
following this molecule, I think.
So that synthesis only, like that is okay. Like I just wanted to know what you will gain from this paper. Just I was thinking, which kind of linker you are also planning to introduce?
Like
By the way, भाई ये मेरा मैं सोच रहा हूँ इसके बारे में बाइपीडिंग के बारे में.
sir told in last two meeting that better to like you did the reaction with anthracene methanol. So better to did the phenol and naphthyl and then compare the three molecules and see this
Okay.
anomeric peak. So that's why.
Yeah, that is good.
If you enjoyed this session, don't forget to like, share, and subscribe. We'll meet you in the next episode, next session. Thanks for watching.